So good morning, I'm Judy Gradwell. I'm President and CEO here at the museum, and I'm delighted to welcome you to the third annual State of Biodiversity Conference Symposium. Here at the museum, we're celebrating 146 years of science. Our anniversary is in 2024, and we have been working for over 146 years on biodiversity in the area. And it is a pleasure to see the community rally around our local ecosystem, which is also, as you know, one of the 35 biodiversity hotspots in the world. We've been dedicated to conservation since we opened since we started by a small group of citizens in the Cecil Hotel in 1874 at that time, I think the entire population of San Diego was around 2,500 people, and yet we had a natural history society that survives today. And one of the first projects was working on preserving Torrey pines. We also did pioneering work on the environmental impact of DDT. Our work continues today with our researchers, and we're working on monitoring the invasive shothole borer, and population assessments of the LeConte's thrasher and seed banking in Baja California's rare plants, just to name a few. But all the projects we work on, we work with outside partners, and we are delighted to have so many people from land agencies, other researchers, fellow nonprofits, government here today, because you are the community we need to work with to try to preserve our ecosystem, our local biome. And it's clear that collaboration is the key to having any success in conservation. So the state of biodiversity is one small measure to try to affect change. Today we're bringing all of you together to talk about our region's ecological condition and how we can work together to conserve our collective natural heritage. So today we have conservationists, land managers, scientists, and concerned public in the room. And I welcome you all and thank you for being part, hopefully, of the solution. And I would like to introduce Michael Wall, Vice President of Science and Conservation and Curator of Entomology, who's going to kick off the day. And this is his brainchild, so he deserves a big round of applause.
Thanks, Judy. I'm going to first start off by using my applause deflector and to deflect it over to you because Judy started working at the museum, the first female president and CEO of the museum, and it's 140 plus history 3 years ago. And this is the third year that we've had a state of biodiversity. So she says it's Michael's brainchild, but it's her vision and leadership that really challenged the staff to engage with the greater conservation community. So thank you, Judy. I want to take a minute to recognize that we are standing on the ancestral homeland of the Kumeyaay Nation, and I want to at least give my thanks and respect to the original caretakers of biodiversity in our region. It does take a proverbial village to pull an event like this off. Part of that village is the State of Biodiversity Advisory Board, also our Binational Advisory Committee, and then a whole bunch of staff and researchers, internal and external, help sort of curate the content of what we're going to hear about today. So if you're amongst one of those clusters of people, if you can just raise your hand and if we can all recognize these folks. Of course, few things happen without expense, and so this year's State of Biodiversity is made possible by presenting sponsor Jane A. Lehman and Alan G. Lehman Foundation, the J.W. Sefton Foundation, and San Diego Zoo Global. Special shout out to the zoo for the help that they gave us this year, with program support from the Downing Family Foundation and our media partner, KBBS. And then finally, I want to thank all the people that are behind the scenes right now. now, making sure that this goes off without a hitch, knock on wood, there we go. Because, we bring off events like this and that there's these, the curators or researchers are out there glamorously working in the field and stuff like that, but there's a lot of work that goes on behind the scenes that supports this mission of conserving diversity in our region, and so thank you to all of our staff. So, why the state of biodiversity? In short, it's because it urgently needs to be part of our community conversation, our cultural conversation. 78 minutes of State of the Union last night with a small throw out to a trillion tree movement to help the environment. 11 minutes of a Democratic response with one phrase about clean water. Kevin Faulkner gets an honorable mention for talking quite a bit about the city's climate action plan and the integration that it's going to take to need to be pulled that off. And, biodiversity and climate action go hand in hand. We don't know what Gavin Newsom said for the State of the State yet, because we haven't had the State of the State yet, but we do know what Gavin Newsom has put into his 2020 budget, and there is a section in the 2020 budget that says modernizing and improving biodiversity protection. So sounds like maybe some money's going to get funneled towards biodiversity. Still, this is concerning that this is the small little bit that we're talking about biodiversity, especially in light of reports that have come out within the last year. In May of last year, the IPPS put out this monumental report that when you read through it can be quite depressing, and it contains a lot of information about biodiversity collapse on a global scale. One of the great things that I think that they did in this report is that they pulled out this exact line here that really highlights that biodiversity conservation just isn't about like saving the fuzzy wuzzies, which is certainly important, saving the fuzzy wuzzies, but really if we're going to drive this conversation forward, we need to start talking about the impacts of biodiversity on us, on human health, on mental and physical health, and quality of life. These are all things that biodiversity to bring to us that are just, I think, overshadowed and not being part of the conversation. More recently, because it's easy to dismiss the IPBS if you already want to dismiss it, right? If you're already in the camp that's like, I want to dismiss all that crazy talk that they've got there, because that's just a bunch of scientists who are like granola crunching hippies, that have an agenda. But most recently, the World Economic Forum put out this global risk assessment for 2020, and number 3 on the list in terms of its severity, the possibility and the impact was biodiversity decline and ecosystem collapse. And so if the insurance folks, if the actuaries and the economists are worried about something, then this does literally mean business. And again, this is going to be part of what we're going to need to do to integrate biodiversity conservation across all facets of what we do as a human species in order to continue to drive forward. So that's why we're doing it. We're trying to shine a light where the light we don't feel is currently being shown. And so we're going to do that today through a keynote address, which we'll have in just a minute. We're also going to have some concurrent sessions. And so in the morning, we're going to have ripped literally from the headlines yesterday, ripped from the headlines. We're going to have a session upstairs on black market biodiversity and violence against conservation advocates. So if you're going to be in that session, you're just going to exit the same way you came in. You're going to go upstairs, and there will be friendly neighborhood staff there to wave you to the classroom that you're going to go to where that session will be held. So if you get lost, just ask somebody and they'll help you get there. That room does have limited seating in it relative to this room. You're welcome. I know we asked you to sign up for different sessions and stuff like that. You can float back and forth between. That's fine and dandy. Just be prepared that if you're going to go to that room, it's a possibility that it's going to be standing room only, so keep that in mind. Meanwhile, down here, we're going to be talking about habitat conservation plans for conservation and discovery. And then we are going to break for lunch, which will be down here. So we'll collectively get together again down here for lunch. I encourage you at that time to go visit some of our partners who have tables up in the atrium where they're talking about some of the environmental education work that they're doing. And also we have Terra Peninsular here, and all this artwork that's on the back walls near the coffee tables and stuff like that was an exhibit that was brought in by Terra Peninsular, and they've got a table down here to talk a little bit more about the work that they're doing. Then after lunch, 2 more concurrent sessions. One of those has to do with the physical and psychological well-being that biodiversity brings along with it, and why conserving biodiversity is important to those things. That's going to be upstairs. Meanwhile, if you stick around downstairs, we're going to talk about San Diego Canyon conservation. Finally, at the end of the day, we'll all reconvene down here. We've got a special panel of guests to have sort of a facilitated beginning conversation that will merge into a town hall. And if you guys have been to this one before, then you know there's always an opportunity for everybody to get a chance to say what their greatest concern is and things like that at the end. But as a postscript to the evening, because you can't do all this stuff all day and get probably depressed without maybe considering a drink. As a postscript to the day, at 3:30, we will be opening up our rooftop for a happy hour. It will only be 1 hour, so from 3:30 to 4:30, and we'll try to kick you guys out by 5 o'clock. But there will be a happy hour on the rooftop. It's a cash bar. There'll be snacks and stuff like that. I encourage you to join us up there. If you've never been up to the rooftop, it's a great view. And there'll be great conversations and great people up there. So that's sort of what we have ahead of us for the day. I'm trying to look over my notes to make sure I didn't miss any of that, and I don't think I did. So, with all that said, it's my pleasure to introduce our keynote speaker. Todd Keeler-Wolf is an ecologist specializing in vegetation classification and mapping. He was the Senior Vegetation Ecologist at the California Department of Fish and Wildlife for 25 years, where he led the vegetation classification and mapping program. During this period, he studied the vegetation and flora of virtually every terrestrial ecosystem in the state, which makes me incredibly jealous. Todd is the author of numerous books, including and the development of the Sawyer and Keeler-Wolf classification system, and most recently the second edition of the Manual of California Vegetation, which has this really sweet online access portal for it if you've not checked that out. Todd also likes to travel widely. I was talking to him yesterday about some work he's going to be doing in West Africa. He's also had some things going on in Australasia, South America, the Caribbean, and he's been a longtime member of the Ecological Society of America's Vegetation Classification Panel. So please join me in a warm round of applause for Todd Keeler-Wolf.
Thank you, Michael. I want to also thank Judy and other members of the museum for thinking of me, and it's an honor to be here and talk to you all. It brings back fond memories. I spent a lot of time in San Diego County over the years. Well, as it became abundantly clear as Michael introduced me, we will be talking about vegetation for the next 35 or 40 minutes, but it's a segue to sort of the fundamentals of biodiversity in the state. And being a vegetation ecologist for the state conferred few advantages, but the best one was that I did get to go to basically every corner of the state and look at habitats and landscapes and biomes and reflect on what I saw. And now I have a chance to sort of synthesize this in a kind of a grand brain dump, which hopefully will be more grand and less scattered. Let's see how I do. If I ruled California, this is sort of what this California state flag would look like. So basically, I want to think of California as this huge swath of Mediterranean vegetation, which is represented by the flowers in the Timber Range taken last spring in a good year. And then that huge range between what we have there and the beautiful desert of Anza-Borrego, which is straight out of the Sonoran world, and the beautiful mixed subalpine forests of the northern Sierra Nevada, which is straight out of the Pacific Northwest Mountains world. So point is, we have a lot here, and I'm going to try to tell you a little bit about why that is and what we have and how we might go about thinking about conserving and maintaining it. So biomes, as you know, are essentially just a reflection of the climatic basis of plant distribution on a very grand scale. This map, I think, has 17 biomes from tropical rainforest to Arctic tundra. And what I want you to pay attention to is there's a very small circle that occurs around California. And you'll notice that California is a nice chestnut brown color, as are several other areas of the world. 4 other areas to make 5 total Mediterranean biomes. So it's a distinct biome because for all intents and purposes, the main reason is plants like to get watered during the season that they grow, and that's absolutely not what happens in California or other Mediterranean climates. So we have an adverse situation that's already set up, and the plants and animals have to adapt to it. So another thing I want to just talk about briefly is what is biodiversity and how do we kind of categorize it? And biodiversity, in a sense, is just you think about the scale of how you look at the biologically diverse entities in the world, and that can be at a very sort of fine scale within a patch of vegetation or on a single island in an archipelago of islands. And that kind of biodiversity of a particular place or a particular habitat is called alpha diversity. Now, beta diversity, in contrast, is if you were to look at that archipelago of islands and look at the 1 or 2 islands next to the island you're talking about and see how those islands differ in their biota, that's essentially the essence of what beta diversity is. It's the act of understanding the amount of turnover or variance or difference between different patches of biodiversity. And that's, spoiler alert, that's California in a nutshell in many ways. And then the final term is gamma diversity, which just means whatever region you're talking about all of the species within that region, within California, within North America, within the world, and so on. So these are all very relative terms, as is the term biodiversity. It's not a competition. We're more biologically diverse than you. It's not that. It's basically that biodiversity confers resilience and stability because of the interaction of the species that are in any given part of that expression of biodiversity. That's the beauty of biodiversity. It's not sheer numbers. It's numbers and representation and functionality. So if we're talking about sheer numbers, which is really hard for us not to, this is my candidate for the most biologically diverse place I've ever seen in my life. It's colloquially known as the Coral Triangle, stretching between Borneo, the Philippines, and New Guinea. And if you were a scuba diver and you had an hour and you knew your fish, you could see over 300 species of fish in one 1-hour dive. Now that's some high alpha diversity in one little patch. And if you were to look at all of the patches, all of the reefs, all of the islands in that Coral Triangle and sum up all the fish, you would be looking at 1,800 species of fish scattered in a highly beta diverse situation. And it's not just fish. You've got the really local endemic species that are only found in one place, and you've got within those places huge diversities of invertebrates. Like it's heaven for nudibranch lovers. There's just such diversity of nudibranchs. There's a huge diversity of crustaceans. And this is what happens in the tropics. You refine these niches of what an animal does into something very small, but very predictable and very stable. So you can actually get species to really speciate in fine ways. So the most terrestrially biodiverse place is a place that's got the sort of the wonders of the tropics. In other words, fine niches, and you throw them into an incredibly diverse topographic part of the world, like the Andes, or Mount Kinabalu in Borneo. And you get this ridiculous number of species because of that telescoping effect on top of this tropical effect of fine niches. So that's super biodiversity. California biodiversity is, it's amazing and astounding in its own right, because relative to any other part of North America at the same latitude, you basically have twice as many species of plants. You've got twice as many alliances of vegetation. You've got, comparable values to a lot of the speciation and the other 4 biologically diverse and biologically hot spots of Mediterranean climates around the world. And the question of why, this is basically a straw man. These are really boring reasons if you look at them. I'm not going to read them because they're so boring. They're so generalized. But there's a story here, and that's what I'm going to try to tell you. Yes, there is geospatial and historic multi-scale effects of climate, topography, and geology on an evolving suite of species in a unique geography. But what does that mean? It's unique. So we'll tell the uniqueness story a little bit. So you start with something simple like precipitation, one of the basic elements of climate. And you've got this elongated north to south attenuation of precipitation declining from the north, where it's really high in Del Norte County, and also increasing as you go north from the south, where it's really low in places like Death Valley and the Salton Sink. And you'll also notice that this attenuation is very gradual. You see the blue color, which is greater than 50 inches of effective precipitation averaged over an 80-year period. That goes all the way down to the southern Sierra Nevada, and also in tiny little pieces of the transverse and peninsular ranges. So even way down in what looks like the red and buffy zone, there's moisture, and that has to do with topography. And of course, topography also has to do with why there's a red zone right next to a blue zone east of the Sierra Nevada crest, rain shadows. There's a lot of local effects that do not sort of speak to you at this grand scale of the California region. But the synthesis that actually helps us understand the stresses of various animals and plants in parts of the state in a grand scale is this notion of bioclimate, which is kind of the synthesis of all the climatic factors that have to do with sustaining life in any given place. How much does water evaporate relative to how much does water accumulate? What's the temperature regime? And you put all those together and you get these kind of these little statements of this is what the hot desert of the Colorado desert looks like. It's very, very, well, as you know, I'm not going to go into it. Highly evaporative, highly dry, highly hot, but never too cold. And then you've got the Mediterranean zone that's in the foothills and in the mid-coastal areas, and that's where it's cooled by maritime effect, particularly towards the coast. And the rainfall patterns are extreme, where you have at least 3 times as much rainfall in the wettest time of the year as you do in the driest time of the year, and so forth. So these are sort of these metrics that are used to develop how we might think about ecoregions or biomes and so forth. Here's a graphic that I took from an airplane a few years ago coming into LA. Obviously, this is the dividing line between the Sonoran Desert on the left and southwestern California on the right. In a winter storm cycle where you see the storm clouds pushing up against Mount San Jacinto and just dissolving as you go just a mile or 2 east of the crest. That is a really good example of a rain shadow. And then you go north, and you don't have the clouds in this picture, but you can look at the vegetation standing from near the top of Mount Dana, which is like 12 or 13,000 feet, and then you go down very quickly to the east to the edge of Mono Lake, and you've dropped 40 inches of rain in about 10 miles. So incredibly steep gradients of various climatic factors in short periods, in short distances. Then you add on geology, which is sort of like the substrate that has the fertilizer or the moisture holding capacity that is necessary for plants. And there's a lot of chemical variation, a lot of variation in general in the geology of California. Again, it's ordered north to south. So if you look at the little, let's see if I can do this. I don't know if you can see that. So there's these purple patches. That's serpentine and related rock. And if you go down from the Klamath Mountains down through the south coast ranges, there's purple patches all along. And so those purple patches are serpentine, hard to live on, but hard to live on under this huge array of different factors, particularly related to climate. So it's like garden experiments, handmade, ready for use and ready for study. Now, synthesizing all of that into a single map is what the people who make eco-regional maps do. And this is sort of a, I guess you could say, a mid-level. There's a hierarchy to a lot of these things. So this would be sort of like the genus, akin to plant species, and the species would be a finer level, and that would be level 4. This is level 3. Holding that constant and putting a facsimile of the shape of California and other places in the United States, even at your basic ecoregional level, you've got twice as many ecoregions in California as you do in the Midwest or on the whole eastern seaboard. So right now, you can already see some differences conferred by that variability in the state. Interestingly, Bruce Baldwin and company at the Jepson Herbarium several years back wrote a paper, and they basically analyzed all the museum herbarium specimens throughout the state. And this is an ecoregional map at about the same resolution as the one that you saw in the previous slide. And then this is an overlay of these centers of endemism. Basically, they looked at these localities for all rare plants, or endemic plants throughout the state. And then they did a similarity analysis, a cluster analysis, to see which ones of these areas were related floristically to each other. And obviously, you can see these different colors. But here's the Mojave Desert. And then you have not only the Mojave Desert, but you have the eastern Mojave Desert coming out, the northern Mojave Desert coming out. And then, here's the Sonoran Desert. All of the plants, obviously, right up to the edge of what would be the ecoregional boundary that the theorist would draw. It seems to be very true to the actual distribution of a lot of the shared rare endemic species that are in that part of the world. Same with the Channel Islands, same with the southern Sierra Nevada, same with the Modoc Plateau, same with the Klamath, same with the coast. So there really are ecoregions, and plants tell us that there are. Okay. So those of you who've been outdoors a fair amount have seen scenes like this. North slope, well-wooded, south slope, grassy. And that's the simple exposure issue of being in the northern hemisphere, where sun exposure makes a huge difference. You would never see anything like this on the equator because it's so constant and the light is so evenly distributed. But this brings in a huge amount of biodiversity just on that local level. And anywhere you go, in this case we're in the Kingston Mountains of the eastern Mojave. On the north slope you have white fir sticking up amongst pinyons and canyon oaks, and then on the south slope you have nolinas and old man beard cactus and a lot of desert shrubs directly over the hill, even though I had to take 2 pictures to depict it. But yeah, it's amazing what differences you can see. And in another way, there's just tons of these juxtapositions based on climate gradients that have more to do with sort of general topography and weather. So everybody who lives in San Diego knows you're going to pay $200,000 more for a house within the fog zone than inland 4 or 5 miles. And plants feel the same way. If they only had money, they'd be great. But basically, we're looking at the coast of California and the Bay Area going down to the Santa Lucias and the fog bank at about 1,500 feet elevation along Big Sur coast. And what this confers is it does really interesting things to distributions of plants. So well inland, in a relatively dry part of the state, you have redwoods in the East Bay Hills in back of Oakland. And those are 20 plus miles away from the coast. And yet they're there because there's a little window in the Golden Gate where fog pours through. Similarly, in the Santa Lucias, you've got fog creeping up these valleys in the summer days, and it just takes a little bit move upslope to get to relatively mesic oak woodland, and then another little bit movement uphill to get to a drier oakland, and finally to very dry grasslands, all within a matter of a quarter mile or so. So. And it's like crossing major states and major countries in some sense. You're crossing a very, very highly telescoped set of biomes. And then on top of that, you basically have, beyond sort of the climatic variables, you have these natural processes. Like in this photo, the eastern Sierra Nevada, you can see that lower left where those stripes of surviving mountain mahogany live that survived or missed getting burned by a fire, which kills mountain mahogany outright. And then uphill from that, you have a bunch of short aspens that have been hit by avalanches on an average about once every 10 years. So they're kept short, but they're still moist enough to grow aspens. And then on the upper right, you have Jeffrey pine, which grows on hot, dry slopes at that elevation. And on the lower right center, you have lodgepole pine, which grows in more protected sort of lowland settings where there's more water. So there's this interplay of different vegetation with different, not only different local climates, but different natural processes and cycles thereof. Very important. Same thing, if you go in the Santa Lucias, you can see, redwood, which is essentially a representative of the Pacific Northwest cold, temperate rainforest, right next to chaparral and open oak woodland and coyote bush scrub. And that's because redwood can stand to be burned. No other Northwest coastal conifer, no hemlock, no Douglas fir, no spruce can stand being burned as regularly as redwood. So it's not just that redwoods grow in cold places. They grow in cold places that also get a lot of fire relative to other places where plants like redwoods grow. So that narrows sort of the definition for redwoods. So this whole thing, you can look at all of these different sort of seasonal and episodic biodiversity examples around the state, resprouting and seeding after a chaparral fire on the left. Incredible diversity that's hidden from view until you burn the landscape. Or in a good El Nino year, you have blooms of Phacelia in the desert. You also have blooms of desert blister beetles that come to eat the leaves of the Phacelia, and that's tied together. And of course, you have west of the mountains these beautiful blooms of wildflowers in a good El Nino year. And on the upper right, you have intermittent washes in the desert, which are required to seed and successfully germinate things like smoke tree and other desert wash specialty species. So the disturbance factors and the adaptation to the disturbance factors are huge. This is not for you to read, it's just to tell you that there are functional traits that explain a lot of the strategies of plants. And one of the things that really should be done, and David Ackerley from Berkeley started it, is an ecological flora of California, where you basically have every one of the main plants that are known from California listed in terms of their life history strategies, their seed longevity, their leaf texture or stem succulents, all the things that are, and more than are mentioned on this particular page. If you know that, you know a lot about what kind of currency does a given plant have to survive in a certain type of environment. So this is a little joke slide, but it's a true story. California's diversity does start with adversity in many ways. And so I decided let's do an analogy with baking something. So you turn your oven to temperate, highly seasonal Mediterranean, and that's when water's not available when plants most need it. And it's, as an aside, California has the most extreme of the 5 Mediterranean climates in the world, so the greatest difference between cold and wet. And then you add a harsh substrate. You can add what we call oligotrophic soils, which are nutrient poor, and you create a Pinot biome, or a Pinot biome, I guess if you pronounced it correctly. And a Pinot biome, Pinot is the Greek word for starved. In other words, nutrient poor and starved ecosystems. And then you just want to check it and see how it's doing. And you never want to take it out of the oven because that would stop the process. So that's enough with that analogy. So going to serpentine, it's a classic oligotrophic substrate. I already mentioned it's sort of attenuated occurrence up and down the state in these little islands of biodiversity that are related to plants' ability to adapt to terrible situations are uncanny given time. And so you've got these places where most plants can't grow, but all over time you have plants that figure out, figuratively, how to grow on serpentine. Now this is the Pacific slope of Western North America turned on its side. And all I want you to do is realize that serpentine crops out as far north as Point Barrow and as far south as south of the Vizcaíno Peninsula, way down here in southern Baja. But the sweet spot is right here in California. And what happens is, it's sort of the overarching principle of limiting factors. It gets too cold and too dark up here to have any sort of diversification of plants. So only the hardiest plants, whether they grow off of serpentine or on it, or on the serpentine way up here north of the Arctic Circle. And likewise down here in Baja, it gets drier and drier and hotter. And until the only plants that you see on the serpentine down there are generalists that live on other poor but non-serpentine soils. But in California, you've got this, come on, oh wait, this way. Amazing sweet spots. The Klamath Mountains, the Coast Ranges, the Sierras all have these strips or individual outcrops of serpentine. And there's just so many little islands where there's been speciation, just as if there were islands in the sea. The Klamaths have the greatest area of serpentine in the state. They also have the greatest topographic relief and range in temperature. And they also have the greatest number of endemic plant species to serpentine. The Coast Ranges are more elongated. There's more mileage between the northern and southern end of the Coast Ranges. But any given part of the Coast Ranges doesn't have as high a species count, but if you add them all together, it's equally high, or maybe even higher than the Klamath Mountains. And so just a huge expression of variables that are sort of in the climatic realm. So that's the little story about serpentine diversity. And then we're going to switch out to the eastern Mojave Desert, and that little push pin there denotes the location of a sample that we did several years ago on what is affectionately known as desert pavement. And it's, in this case, quaternary intermittent aged alluvium, the QIAL, in that polygon right there of a surficial geology map. That tells us that there's over 100,000 years of age of that particular surface, maybe as old as 250,000 years of age. And basically, it has been untouched, relatively speaking, for that long. So you can see how baked, literally, the soils look there, or the surface looks. There's no soil. And basically, that's the desert varnish that builds up over thousands of years of sun treatment and exposure. And this is what it looks like on the ground. It's hard to see any plants on that particular surface between the two yellow marking pins. But if you go close, hey, you can see things like Phacelia neglecta. You can see things like Alicia latifolia, used to be known as Gilia latifolia. These are desert annuals that do amazingly well in amazingly horrible situations for most plants. And they have the secret strategy. They have seeds. They have seeds that are genetically different. They have seeds, and some of them will germinate only in super wet years or in years where there's multiple wetting cycles throughout the wet season in the desert. They have seeds that will germinate even with the slightest amount of water once during the year, just enough to wet the seed coat and get them going. And in that little handful of Alicia seeds, there's probably 3 or 4 different strategies of seeds that are genetically pre-programmed to sum up and become a good bed hedging strategy for desert annuals. This is what many plants do to one degree or another in California. The annuals rule by ducking and covering, and by hiding from adversity, and by waiting it out, and by having the ability to wait it out until there's a high likelihood of them surviving. So that's pretty amazing. Now we go back to the coast and we look at California's answer to the Galapagos, which is kind of a joke, but it's very similar. These are the outcrops of maritime chaparral, which also occur on these oligotrophic soils. They're not serpentine, they're sandstone and other substrates, but poor in nutrients, hard to get roots through. And they crop out in these small to mid-sized patches all along the coast. And unfortunately, they also tend to be very close to centers of great population. This is Cabrillo National Monument. This is Montara Mountain, which is just south of Daly City in San Francisco. And yet, there's so many species of things like, there's 30 species of manzanita, there's 18 species of ceanothus that are endemic, as well as other shrub species and herbaceous species. So incredibly diverse because of this little sweet spot of relatively moist but relatively harsh at the same time. And the harshness comes into play because all other things being equal, there would be oak woodland, or there might be coastal sage scrub, or other things growing there. And they're not growing there because they can't stand to grow there. So this is just a little summary of how different maritime chaparral species are based on some work that Mike Vasey did several years back. And they're different. They're much higher in biodiversity and so forth than your more typical inland chaparral. And this is one of the things that they have to resist if you're a shrub in maritime chaparral. You're going to know that these trees are going to be encroaching on you. You're going to know that you're basically going to end up living in the understory, and you're going to be shaded out, and you're going to die, and you're going to live through your seeds until the next fire or disturbance comes. So it's another long-term strategy. And this is kind of what it looks like to be in the middle of a little patch or 2 patches of maritime chaparral in the coast, well, actually the eastern Bay Area hills, the Oakland-Berkeley Hills, where we have Arctostaphylos pallida and Arctostaphylos crustacea as kind of the main manzanitas. So poor soil, in this case it's shale, really lousy soil. And that soil crops out in these teeny tiny outcrops, and they're surrounded basically by pretty dense shady oak woodland or houses. And therein lies the trouble. Will you be able to burn right next to those houses and set back the clock for the maritime chaparral stance? Or will you have any ability to control for their existence at all? I mean, how long can a seed bank of Arctostaphylos pallida wait to germinate? We don't really know. So there's a whole lot of other things about California that sort of smack of adversity. Some of them are secondarily adverse, and one of them, I think, in a broad sense, are these beautiful wildflower fields that crop out in different parts of the state. Where you see them now, because of the invasive exotic annual grasses and other annual non-native herbs, you see them on poor soils. And you see them on, these harsh shale outcrops, or you see them on alkaline soils of the Carrizo Plain in a good year. And you see them in the Antelope Valley in a good year. That doesn't mean they weren't a lot of other places in California before the introduction of non-natives. They just have been fortunate enough, by virtue of their abilities to be adaptable, have found a place where the non-natives don't compete with them as much. The same is true for these nice patches of perennial grasslands that are found on serpentine soils. And there's an example very quickly of that. You blinked, you'd missed it. Sorry. I'm not going back. Anyway, there's just a whole suite of these beautifully, narrowly adapted vegetation types and, in a sense, biomes. One of my favorite, recently discovered from doing a lot of sampling and mapping on the Channel Islands, is the Dudleya Alliance. So there's several species of Dudleya that live along the central and south coast. They grow on steep slopes, and they have their abilities to adapt. They love being in the maritime setting, but they definitely can hold water in their leaves a long time. However, it's incredibly localized. There's just a narrow band of sea cliffs where they live, and people are hiking over those sea cliffs and thieving succulents to sell on the succulent trade, the black market, if you will. And so there's problems there, obviously, because of the limitations. Many other examples. I don't have time, obviously. There's fens, nutrient-poor wetlands. There's calcareous soils like limestone and dolomite, and they have their own endemics. There's mountaintops, obviously, which have climate change is kind of the scary factor there, where you're going to be squeezed to the top and then there's no other place to go. All of these things vary regionally throughout the state. So you've got a lot of different types of each of these situations, sort of culminating in huge diversity. One final topic that leads into a little bit about conservation before I finish is vernal pool ecosystems. So vernal pools are another example of the Mediterranean climate ecosystem. And I mean ecosystem, you think about the pools, but really when you look at the way these pools work and the way that these flowers in the pools are pollinated, they're pollinated by andrintid bees that dig little burrows in the interpool uplands, basically the mounds between the pools. And if it wasn't for the mounds, there wouldn't be the bees because they couldn't find a place to live. So this is a landscape, a true landscape that's interactive. And of course, there's just a great diversity of them. And there's also a huge impact, particularly in the coastal areas of Southern California and in the Central Valley, of development in agriculture and various other generally termed development factors. And so one of the biggest and earliest of the big recovery plans that the U.S. Fish and Wildlife Service started was the Vernal Pool Recovery Plan for primarily the Central Valley vernal pools, because everyone thought, well, we know those the best, and there's a huge amount of impact, the spreading footprints of the megapoli of Sacramento and Fresno, et cetera. And so you get these situations where the pool landscape is just being crowded out. So big recovery plan, but I'm not sort of casting aspersions at anybody or anything in general, but it was sort of getting the cart before the horse, because we knew something about where the problems were, but we didn't know enough about how to solve them based on sort of species distribution and endemism, and therefore that bottom bullet, which is referring to the fact that we didn't know about essentially the equivalent of ecoregions on the vernal pool level. Where do you start and where do you stop mitigating in kind before you shift to a whole other palette and you have to think about other species? So, yes, we found out that vernal pools vary regionally, as do their threats. We found out the regional variation is very important in how to look at pool sustainability, how to map them, and so forth. And this is an early mapping effort that's actually been very valuable to sort of depict how changes can occur and how to look at pools from the standpoint of just pool density per landscape unit. Then you can go back 10 years later, which was done, to see what kind of changes there are, losses, and so forth. And this is a segment of that work that was done by Carol Witham and Bob Holland and others, where they're basically showing these brown margin areas that are sort of the pool reserve areas, and then insert, various types of mitigation, in some cases that are occurring outside of a region. They were creating pools here, which, in hindsight had a relatively low probability of success because they're outside of the region. So the more you know about your ecosystem in terms of mapping and specificity, the better off you are in terms of doing conservation work. Now, this is the scariest story to me right here. And I'm going to just exemplify it by talking about cheatgrass in an area east of the Sierra Nevada where our State Fish and Wildlife had a wildlife area. This is just an air photo taken in 1998 of this area. And then in 2004, there was a fire that burned everything. You can see basically dead trees and scorched earth. And then a year later, you can see this, haze of sort of cinnamon-colored grass, which is all this, cheatgrass. This is what it looked like about a year after the fire. And it forms a great fuel for more fires. So cheatgrass comes by fire, begets more fires. And this is that same area about a year before another fire that I had, I would say, the fortune of being present for. It was really interesting to watch the behavior of fire in a cheatgrass infested area. So there's where it started, a lightning strike. There's a picture of it. Slack winds, no winds blowing, but 10 minutes later, the wind started blowing. The fire raced upslope. That picture was taken less than 5 minutes after that first picture. So it covered about 1,000 vertical feet and about a half a mile in about 5 minutes. And this is what the footprint of that fire looked like. So how long do we, what are the chances of recovery before another fire hits? That's the real worry, because many of the species in the Great Basin are not fire adapted. Here's a case in point. Eco-regionally based scary story. Modoc Plateau. Low substrate diversity, volcanics, low topographic diversity, rainfall diversity. It's a plateau, after all. And relatively low plant species diversity and vegetation diversity. That's geology, it's all volcanic. But, there's some beautiful, beautiful landscapes where you have low sage and, a huge array of annual and perennial grasses and forbs, really high alpha diversity, surprising, like 50 species of vascular plants in 1/10 of a hectare. That's pretty high for a dry California vegetation type. But this is what it turns into. So this is not cheatgrass, this is Medusahead, which tends to grow better on very heavy clay soils than cheatgrass does. But we had to walk 3 miles because we didn't want to drive across it and spread more seeds to get to this little site that didn't have much Medusahead on it. So that's the trail of our path there that you can see. But it's just thick and horrifying, and the thatch remains there for years after and can burn at any time. So that's kind of the story there. This story can be replicated using different species of annual grasses and forbs that are introduced in the eastern Mojave or the inland empires, coastal sage scrub. The non-native grasslands and herblands are taken over in large parts of the state. And that's the biggest, scariest, hard to stop, hard to conceive of stopping process that I see in terms of biodiversity loss. One good thing is that we can map now. We know where these things are happening, and we can also know where things shouldn't be allowed to happen. So this is just a schematic of what it looks like from the ground to look at vegetation types in western Riverside County. This is what it looks like from the air in a different part of California. We can actually divide these things up finely. They have good, reliable names. Accuracy is good because we have samples everywhere, and we can co-locate samples and understand the needs of different vegetation types. There's information on structure and cover, which lead to modeling for habitat, in addition to just understanding what type of vegetation is there. And we've done this on 60% of California, and we're still working away at it. But it's a slow process, and it takes money. But we can do really interesting things now. This is a project I was talking about to some people before this, where we're up in the Modoc Plateau, and we're looking at the spread of the red, which is non-native annual grasslands, and its relationship to birds that were censused via remote automated recording devices throughout different vegetated types of the Modoc Plateau that we mapped. And the only 3 species that are doing well with non-native exotics are ravens, horned larks, and meadowlarks. You might expect that. Ravens can live anywhere, and the other 2 like short grasslands of any type. But there's been a lot of loss of various sparrows, sage thrashers, et cetera, in huge parts of the Modoc Plateau. So we're taking this information of localization and representation and understanding things at sort of a sub-regional level to a huge 22 million acre area in Eastern California, the Desert Renewable Energy Conservation Plan area. The great thing about this project for me was that we actually were able to tell the players in the room sort of what we thought would be most important. We got a good map for most of the affected area of the vegetation. We got conservation rules written into the rule set of the plan that looked at the patterning on the landscape in the subregion, which was great. And here's an example of, we did a good job protecting the poppy-colored patches in the Antelope Valley compared to where the new solar farms are. There's not very much overlap at all. They listened to us and they followed the rules, which was kind of astounding to me. Whoever they are, I don't know who they are. So final story here is that we've got this beautiful, weird Pinot biome or oligotrophic biome, the pygmy forest of Mendocino coasts, and it's never ever been sampled and understood, and therefore there were all kinds of descriptions and definitions of what was pygmy and what wasn't pygmy, and that was very germane to this problem, which is most people want to build their houses where there isn't forest, because you cut down the forest and you can make money. And so you build your houses on top of these mesas of pygmy forest. So there's a lot of these little individual mesas, 30 of them up and down that 70 miles. There's a great disparity in growth form and species composition between the adjacent vegetation, redwood, for example, and the pygmy forest. And we went out and sampled it. We allocated samples everywhere in different representations of soil types, and we came up with a classification that told us that there were 6 different vegetation types, each with slightly different environmental requirements that lived on these pygmy forest islands, if you will. And that meant we were able to map it very accurately, and that meant that we could also look at the footprint because these islands are so visible. Soil mappers had mapped them years ago. So we could look at the footprint of a place like this and say, this is how much was lost. And the ability to say things in the terms of loss are very convincing. And we had this huge array of people that were actually convinced by this, from county planners to, owners of timber companies. And they are working with that map to do conservation planning, acquiring lands for state parks, having easements, and so forth. So, success story. So there is hope. I just want to end with this. There really is hope. And it's not just that we're getting better at doing assessments and being more convincing with our arguments, but we're blessed with this incredibly diverse and complicated part of the world. And it is confusing to the uninitiated, but it's delightful to the person who wants to know about it. And the reality is, we have so much resilience built into the landscape facets, to the different soil exposures, to the northness versus southness, to the coastalness versus the inlandness, that we're in far better shape in terms of maintaining overall biodiversity in California by far than, let's say, an east coastal area, where one of the major trees, the American chestnut, completely died out in the order of 40 years because it didn't have enough genetic and landscape diversity to give it a leg up. So we are lucky. We're very lucky, and we should know that we're lucky. So we got to think about these geographic gradients. We have to represent the regional and the local. We have to be really aware of these areas where there are high gradients, where changes are happening, and particularly aware of introductions of species that have a very different functional suite of traits, like these non-native annual grasses. And we need to educate. Last thing I'm going to say, this is a map of the tribal boundaries, plus or minus, of the 135 some odd Native American tribes as of the year of contact, more or less. And look at the similarities with the ecoregions. This is the thing that is just wonderful. So I definitely want to thank everybody that's influenced my ability to know a fair amount about the California landscape, but I really want to thank traditional practitioners of biodiversity and sustainability, the tribes, because they basically knew how to divide up the landscape and live on it for thousands of years. And, we really need to understand how that was done. And their patterns reflect other biologic patterns, which, as it should be. So I'm going to leave it at that. Thank you very much.